Thank you,
Hello,
Professor
Pedro.
Tugrul. Hello, Tugrul Ozel, for
Yes,
presentation.
hi.
I'm going to share my screen, sorry.
Mm-hmm.
Just a second.
And this paper is from Portugal.
Yeah.
Universidade Nova de Lisboa, from Lisbon.
Yeah, it's sorry, I'm just having a little bit of trouble sharing.
Maybe Antonio can give you the privilege to present.
So I guess Pedro exited the session. Maybe he is rejoining.
Okay, maybe that would help.
Yeah, let's wait a couple of seconds.
How is the weather in Calabria?
Well, actually a little bit raining. The temperature is not very cold yet, but today is a rainy day.
Mm-hmm. You're not far away from Barcelona, but looks like the weather varies across the Mediterranean Sea.
Yeah, that's correct.
Mm-hmm.
We had very cold days over the last weeks, and then the temperatures went a little bit milder. But you know, winter is coming.
True. And it's climate change, so we get very kind of different weather all the time. Okay,
Hello.
Pedro rejoined.
Hello, sorry, my Microsoft Teams closed during my screen share. Let's try again.
Yeah.
Okay, let me choose my screen. Okay.
Perfect.
Very good.
So can you see my screen, please?
Yes.
Okay. Thank you. Good afternoon to you all. Again, sorry for this little issue I had. So my name is Pedro Espadinha-Cruz. I'm a professor at Nova School of Science and Technology from Nova University of Lisbon in Portugal. Today I'm presenting a research that is conducted by my master student. Her name is Soraya Diaz. And I'm responsible for this task in a project also with Professor Florinda Matos, the project called KM3D. So first of all, I'm going to make a brief introduction about what is the main issue in this research and the research objectives. Then I'm going to provide a slight background for some of you that are new to additive manufacturing. I've seen the previous presentations are more advanced and more technical than my presentation. Then I'm going to explain our proposed approach and present the conceptual model results. So, as a context, the main driver for the fourth industrial revolution is right now called the Industry 4.0, that contributed to new disruptive technologies such as the additive manufacturing. And additive manufacturing right now it's not really not necessarily new. It has some decades, but right now it's advancing more rapidly than it was before. Joining this with the increased competitivity and rivalry lived by today's firms, and also the higher demand from the customers in terms of diversity and also some quantity, and the shift from a material economy to a knowledge-based economy is leading to the emergence of new additive manufacturing business models. So the question that we raise in this research is, how does the additive manufacturing impact the business strategy? So two main objectives that are actually they are related. Is the first objective of our research is to study the impact that additive manufacturing technology has on business strategy, and we want also to wanted to also identify factors that enable the alignment of business strategy with existing industry conditions. So like I said before, Industry 4.0 is right now a vector that is leading these technologies to advance rapidly right now. So additive manufacturing is a technology that mimics biological systems building parts in layers. So it enables the fast development of products through additive process instead of subtracting technologies or molding technologies like in conventional manufacturing. And this technology is running, like I said in the previous slide, it's running, is gaining a lot of visibility due to the technological evolution of machines and also materials, and also the ability to provide some of these technologies at a low cost to end users. On the other side of the coin, we have also additive manufacturing is one of the Industry 4.0 technologies that is contributing very high to the Industrial 5.0 and smart manufacturing paradigms. For instance, one of the benefits is the ability to mass customize the production. Also, the manufacturing is benefiting also from rapid prototyping using this technology. That is not really new right now. It allows us also to produce sustainable products, producing with less energy and less materials than conventional manufacturing, or at least producing less waste than the conventional manufacturing ideas. And also other developments like bioprinting or metamaterials printing. Moreover, to small companies and to end users, this technology is also allowing those actors to participate as designers and also as manufacturers in a smaller scale right now, but they are beginning to participate in AM businesses today. So this advances and also the potential benefits that additive manufacturing are contributing to existing and new businesses models that are going to change more the next business paradigms in use of this technology. For instance, I'm going to refer to some specific, not all the examples on the slide. For instance, it is believed that once this technology is more advanced and it allows us to build in a smaller time and with high complexity products, possibly in supply chains, is going to contribute to decentralized or centralized approaches to supply chain design. Is going to change, for instance, the spare part industry, like in automotive, where instead of automakers have to create inventories of 10 years for spare parts, they can have only the schematics, the CAD information, the CAD data to build spare parts in the lower time without having capital invested in the material inventory. Other examples, for instance, also the consumers right now are building spare parts or products for consumption and sometimes for selling. So it means that this technology has the ability to change a lot of the business models that exist today. So the question is, how does this impact the strategy? To address this question, so we pose the two objectives, and to address this question, we propose to use a simple model provided by Michael Porter that derived from the five forces model called the structural analysis of industry, because it seems fit to identify the critical factors that are going to influence 5 different aspects of company positioning. Here we have the model. So the model has 5 different forces. It considers the actors outside of the company's view. We are looking at suppliers and also customers, and also we are looking to possible competitors in three different dimensions, as we see in the middle. So to approach this research, we propose this methodology. This is right now. This work reports a very conceptual phase of this model. So we started by formulating objectives and to conduct literature review in additive manufacturing and also in additive manufacturing impacts in business models, to track how what factors are influencing the company's decision making when they set their strategy and they design their business model. So in this paper, we refer to the three first tasks and also to the last tasks, but in only a theoretical perspective. The practical validation right now is still in progress, but it's not reported on this presentation. So based on literature evidence, we identified these factors that we have on this slide. For instance, from in the perspective of the threat of new entrants, or new entrants in the additive manufacturing markets, we have issues like, I'm going to explain this further next. Extended producer responsibility, that it was issued by European Parliament in the recent years, that are going to change the market. At the middle, we have the position of the rivalry among existing competitors and the forces that are going to condition new businesses in this area. So I'm going to explain this in the next slides. So addressing the first one of the five forces of Porter, like what I was saying, extended producer responsibility could be a new threat to new entrants. This directive was issued in the last years by our European Parliament, saying that producers must have resources to deal with end of life products. This could be an opportunity for businesses that already are well set and they already apply additive manufacturing, or at least they are using it in complement with other kinds of manufacturing. But for smaller producers with low resources and not very low capital investment in materials, it's going to be difficult for them to join this market, for instance. Other aspects that we have here is the knowledge and experience, because this is it's not very new technology, but right now it's still evolving and very fast, and it is necessary for companies to adapt, to change, and to adapt to new knowledges. So early adopters of additive manufacturing are going to get an advantage faced with the others. The others that are still using the traditional manufacturing, that is going to be here for a long period, but they will have to make they'll have a greater barrier to join the market if they don't keep up with the new knowledge. From the customer side is very curious, because customers are now allowed to participate in these technologies, because with the emergence of 3D printers, for instance, a lot of users today can print their own materials, and so they are going to pose a threat to existing manufacturers in different perspectives. First of all, this is called the democratization of manufacturing, saying that some users right now, without any manufacturing skills, physical manufacturing skills, like when we use a router, for instance, to build the materials, maybe they have to know a little bit about materials, but if they can design the products using CAD software, they easily can build some products. This is called this movement is being called the prosumers. So these consumers that are able to produce new products. Also, other aspects that we have here, the extended user responsibility, this is being legislated at least in Europe. So saying that not only in Europe, I think in the United States also, giving the right of users to repair their own products without infringing the warranties. Okay. From the new substitutes parts, that means the possibility of new products enter the market and act as a replacement for existing markets. We have two main factors here. The first is the swap and grow providers. That means the companies that are allowed to make repairs on products and design upgrades or design a different part for a modular product, they easily can join this market and also replace the existing production production of components of a product. Also, the conventional manufacturing right now is still here. So while additive manufacturing is now maturing, it doesn't replace yet most of the conventional manufacturing. So they have a lot of issues to overcome. So the standard products are going to still be to be a threat in this market. Looking at the suppliers it's have a different perspective. It has a more broad perspective than the aspects that I said before, because what I said before, it's a threat maybe firm to firm, but when this technology advances to the point where we can build very complex material, very complex products, and they can be produced everywhere, they are going to maybe provoke two changes on supply chain design. For instance, by decentralizing supply chains, we are going to have shorter supply chains, and also this is going to contribute to reducing the inventory, the material inventory, to shifting to digital inventory, meaning that we need less of inventories in storage, but we can have digital products. Another phenomenon here, it's called the glocalization, because the manufacturer can be placed close next to the final customer. That is related also with the first, because we can reduce the tiers of the supply chain, and displace the location to manufacture the high personalized products. In the middle, we have the rivalry among existing competitors. There is a key factor that is interesting also, because the rivalry is going to be a key factor inside rivalry. It means that since additive manufacturing allows for fast production and reconfiguration, it means that theoretically the same equipment can build different kinds of products. It means that simultaneously a company that uses additive manufacturing at the same time can serve different purposes inside different supply chains. They can act in different markets at once to propose new products. Also, other aspects regarding this. Regarding intellectual property rights, there is no actual regulation for open business models. Intellectual property rights mostly they act on closed business models, like automotive, for instance. Every knowledge is regulated. When it comes to end users and also maybe fab labs, it's easier to use knowledge that is, while it is protected, it's not being regulated right now. How schematic for a product is shared over internet, for instance. So this is going to become an issue because everyone can build a product that fits, build a component that fits the product, but it's not really regulated, and this is going to be compete against the existing manufacturers. So let me see the time. Sorry. Do I still time? Okay,
2 minutes.
2 minutes. Okay, sorry. So I'm going to finish. So as you can see, this new form of production will directly impact existing manufacturing models, and also is going to impact the businesses. This is going to allow another business models that completely can disrupt the existing business models, or that means that this technology can replace, at some point is going to replace the conventional manufacturing in some areas, not totally. Our aim was to build a model that can be adopted and adapted by researchers and stakeholders. So it means that it helps companies and also researchers to position their developments towards the existing market to identify what are the main issues they have to overcome for them to enter this market. Okay, that's it. Thank you.
Thank you. This was a very interesting presentation, very different aspect, the supply chain effects, and we appreciate. We're just running out of time for questions, so I'm just going to start at the next paper. And if you have questions to Professor Pedro Espadinha-Cruz, then we can get in touch with him during the network or through email.
Okay.
Thank you very much.